for ionic compounds, and recall that ionic compounds are characterized by having ionic bonds between a metal and a nonmetal. With an ionic bond, we have two different parts. We have the positive ion, which is usually listed first, and that's called the cation. And we have the negative ion, which is the anion. The naming of ionic compounds simply involves putting down the name of the cation and the name of the anion. So for instance, if we looked at a common compound, ionic compound like sodium chloride, NaCl, given away, we would use the cation of sodium, which happens to be the a metal in the first column of the periodic table, and the chlorine, and similar to the covalent substances, we're going to change the ending on chlorine to "ide", so chloride, so sodium and chloride. Cation part, anion part. Let's take a look at each of these parts a little bit more carefully. The cation part, again, is the metal. Most times this is going to be the metal name. Excuse me. So we have sodium chloride, potassium chloride, calcium chloride, strontium chloride. So it's just the metal name plus the anion part. There is one polyatomic anion that we're going to be responsible for. Polyatomic meaning multiple atoms. And that is NH4 with a positive charge. So this is a cation, and this is called ammonium. The ammonium ion. And then finally, we have some metals that can have several different ions. And so if we took, for instance, iron can make two different compounds with chlorine. We have FeCl2 and FeCl3. Obviously, we can't call both of these iron chloride because they have they're different compounds. In the first one, iron is going to have a 2+ oxidation state, meaning that it's given up 2 electrons. So we're going to call that iron, and because it's a 2+, Roman numeral 2, and then chloride. Similarly, the second one would be iron. And now we look at the iron again, and we see that here, each chlorine took 1 electron, so this iron must have given up 3 electrons, so it's got a 3+ charge. So this would be iron 3 chloride. Right. Again, it's important to remember that the Roman numeral refers to the charge on the iron and not how many chlorides that are connected to it. The other metals that we're going to be responsible for that have multiple oxidation states are listed here. So in addition to iron, you've got copper, cobalt, tin, lead, and mercury. So again, there's 6 of them. Just need to kind of remember them. You can identify them. They're mostly in the more of the center region of the periodic table. And again, we'll do practice with this in class to make sure that you're familiar with these. The anion part, the easiest thing is if we have a single element as the anion. In that case, we drop the ending on the element, and we add the "ide" ending. So oxygen becomes oxide, chlorine becomes chloride, Fluorine becomes fluoride, and we can actually go through all of the nonmetals rather quickly. Nitrogen nitride, sulfur sulfide, bromine bromide, iodine iodide, nitrogen nitride. So it's pretty much all of them. So there aren't too many single element anions we have to worry about. However, there are several polyatomic anions that we have to memorize. And so these are anions that have multiple atoms together. So for instance, this ion, NO3 minus, this is a nitrogen and oxygen, excuse me, nitrogen and 3 oxygens that are combined actually with covalent bonds, because they're all nonmetals. But together, in order to create that anion, it needed one electron to be added to it. So that's why it's got a -1 charge. So this ion here is called nitrate. We're just going to have to kind of work on learning these. There's going to be, maybe about 15 or so that are commonly used that we're going to have to memorize. Most of the time we can, use a little bit of systematic learning of these. So for instance, in addition to NO3 minus, there's an NO2 minus, which is nitrite. So you can see the name is very similar. The only thing that changes is the ending. And so we'll work on learning these different ions together in class. So that's about it for the naming of the ionic compounds. Again, it's just going to take some practice, and the more comfortable you are, the more of the ions you have memorized, and the more of the elements you have memorized, the easier this is going to be.